The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for our first test, which is tomorrow. Just a reminder, I would advise you to go back and read the test taking policy and the test taking strategy. Just a couple of things to remind you about the strategy. So as you go through and you are finished with the test, if you want to email me the work that you did for problems that led to wrong answers, I will look at your work to see if there's anything correct there to give you partial credit. But if you go back and you correct the mistakes and email me that, I won't even look at it. I'll just say, oh, didn't follow the directions. I'm not interested in whether you can correct it, but well, I mean, I'm interested in that, but not going to give you credit for it. Just any questions about that? All righty. Well, let's get started. This is for your benefit. I don't have any agenda other than to answer questions. If you have specific questions you want me to look at, that's great. Tell me what they are. Otherwise, I'll just kind of go through the general sections and maybe highlight some points. But anyway, I'm just going to open it up now. Anybody have anything they'd like to look at?
Can you touch on the absolute value again, like the last two questions on the review?
Absolutely. All right, just a question. Do you want me to look at one specifically like that or just absolute value in general? Darian?
The first one with the absolute value.
Okay, and let's see, that's in order of operations, I do believe. Yeah, so, and assignment. Okay. Now, the one I pull up may not be exactly the one that you did. If you want me to do exactly that one, let me know. Otherwise, I'll just look at some that are similar. You said the first absolute value one? Was that it, Whitney?
Yeah, it was like negative absolute 6.
I got it. Okay. So this is one. This is what I see on my screen. Negative, the absolute value of 2b minus g plus the absolute value of negative 4w. Okay, so we have the variables b, g, and w. It says where b equals negative 4, g equals negative 5, and w equals negative 6. So what we're going to do first off is replace the variables with their number equivalents. So negative 4 is going to go in place of b. Negative 5 is going to go in place of g. And negative 6 is going to go in place of w. So what's that going to look like? It's going to look like this. Negative, the absolute value of 2 times b, which is negative 4, minus g, which is negative 5. Just a reminder, whenever you replace a variable with its number equivalent, put parentheses around the replacement, plus the absolute value of negative 4 times negative 6. Okay, before we go on, any questions about what I just did? All right.
For me, it was more at the end.
Okay, so now following order of operations, absolute value bars are grouping symbols, so that falls in the same category as parentheses. So we're going to do what's inside of the absolute value bar, what's inside of the absolute value bar from left to right. Okay. All right, so inside the first absolute value bar, I've got multiplication, 2 times negative 4, and subtraction. I'm going to do the multiplication first. So 2 times negative 4 would be negative 8. And then I've got minus negative 5, right? But subtracting a number is like adding its opposite. So that becomes -8 plus 5. So far, so good?
Yeah.
Okay, then continuing inside the absolute value bars, -8 plus 5 would be -3. Do I need to go over how I got that, or are you okay with it?
I'm good. It's right there that I get confused.
Okay, now you might think, well, negative times negative is positive, but you can't cross absolute value bars. You have to get rid of them. So my next step is to take the absolute value of -3, which is 3. Then this negative sign that's been traveling along all the time comes and hits it once the -3 becomes a +3 on the outside. Okay. So again, order of operations, you do the grouping symbol first and then deal with what's outside. We all right with that?
Yeah, I think that's the part I was getting lost on.
Sure. Okay. Now let's go on. Oops. We've got inside this absolute value bar, set of bars rather, -4 times -6. Negative times negative is +24. But the absolute value of 24 is 24. So we get -3 plus 24, which is 21. Final answer. Any questions on any of those steps, folks? All right. Should I go ahead and do the second one, the last question in that set? Another one of those? Okay. Take a look at that. We good to go on? Yes. All right. The next one says evaluate. Oh, what does evaluate mean? It means basically find out what its value is. You know, plug in all the numbers, do all the operations, simplify it down to here's the final simplified answer. It's not solve it. We're not doing equations. It's just calculating what it's worth. All right. So we've got evaluate negative the absolute value of 2b plus 4g minus the absolute value of -5w. So the main difference between these two problems is that the first one you're adding two absolute values. This one we're subtracting two absolute values. Where b equals -2, g equals -9, and w equals -4. Okay. So once again, we're going to make substitutions. -2 times b, which is -2, plus 4 times g, which is -9. Minus the absolute value of -5 times w, which is -4. So after making the substitutions, we've got that. Any questions? All right. So inside the first grouping symbol, the first absolute value bars, we've got multiplication, addition, and multiplication. So we're going to do the multiplication first. 2 times -2 is -4. Plus 4 times -9 is -36. Any questions there? Continuing to simplify. -4 plus -36, adding two numbers with the same sign, have their absolute values. 4 plus 36 is 40, but then attach the common sign. So that would be -40 inside the absolute value bars. Finally, the absolute value of -40 is 40, and we've got this negative sign outside. So once again, we've got that situation. Again, you've got to get rid of the grouping symbol before you attach whatever's outside of it. All right, minus, minus, minus. Second absolute value, -5 times -4. Negative times negative is +20. Still inside the absolute value bars. We simplify it inside down to a single number and then take the absolute value of that number. The absolute value of 20 is 20. So we get this, negative 40 minus 20, which is negative 60. But if you need to change it to addition of the opposite to see what's going on, that's great. Adding two numbers with the same sign, add their absolute values, 40 plus 20 is 60. Attach the common sign. Final answer, negative 60. We okay with that? Do you want some more examples? What? You tell me.
Can we do 37?
Which one?
37.
37. Now, is this from the chapter review or what?
Yes.
Okay, chapter review. All right, let's see here. Ah, right, more absolute value. Do you want me to just do what one in front of me, or do you have a specific one that you want me to do? Because your 37 might not have the same numbers that mine does. Does it matter to you? No, okay, all right. Okay, this says evaluate. Basically, it's very much like the one we just did, different numbers though. So we've got, oops. Nothing wrong with blue, I just like writing with the black better. So negative absolute value of 3c minus k plus the absolute value of negative 4x, where c is negative 2, k is negative 9, and x is negative 19. So again, first thing, making the substitutions. Negative, the absolute value of 3 times negative 2 minus negative 9 plus the absolute value of negative 4 times negative 19. Okay. So now, starting with the first absolute value grouping symbol, we've got multiplication and subtraction. 3 times negative 2, positive times negative is negative, negative 6. Then the subtraction, minus negative 9 becomes plus positive 9. Subtraction of a number is addition of the opposite. So we get negative 6 plus 9. Adding two numbers with different signs, subtract the smaller absolute value from the larger. 9 minus 6 is 3. Attach the sign of the number with the largest absolute value, which was positive. So we get a positive 3. The absolute value of 3 is 3. And on the outside, we have a negative sign that hits it. Okay, going on. Second absolute value, negative times negative is positive. Let's see, 19 times 4, 6, carry the 3, 76. So that would be the absolute value of 76. Again, you simplify what's inside before you take the absolute value. Don't do it all in one step. Absolute value of 76 is 76. Adding two numbers with different signs, subtract the smaller absolute value from the larger. 76 minus 3 is 73, and attach the sign of the larger absolute value, which is positive. So final answer, 73. Okay with that, Ellie? Okay. All right. Others? Anything else you want to look at?
I have a question.
Yes.
Well, I have it here in front of me.
Okay. You want to just tell me what it is?
Yeah, it is, so 5 and 5/9 plus 9 and 13/15.
5 and 5/9. Is that right?
Yeah,
Plus,
plus 9 and 13/15.
so,
It says to write as a mixed number.
okay, so have I got that copied correctly?
Yes.
Sorry, your voice is a little muffled for me, so I wanted to make sure. Okay, so the first thing we need to do is get a common denominator for 9 and 15. So let's take a look at the prime factorization of each. 9 is 3 times 3, or 3 squared. 15 is 3 times 5. So the least common denominator is equal to the product, so multiplication, the product of the highest power of each different prime factor that's up there. Okay, so we've got 3 squared and 3 to the first power, which is higher, 3 squared. So we don't put them together, we just take the one that's the highest power of 3, okay? And then the highest power of 5 up there is just 5 to the 1 power. So our LCD is going to be 9 times 5, or 45. So any questions about what I just did there? A common mistake is people think they need all 3 of the 3's, this along with that. You just take the highest power. Okay. So now I'm going to change the fraction part of my mixed numbers into fractions that have the common denominator of 45. Okay. So I'm just dealing with the fraction parts, not the whole number parts. 5/9 needs to be something over 45. So I'm going to multiply the denominator by 5. 9 times 5 is 45. Consequently, multiply the numerator by 5. So the new numerator is 25. Any questions about that? I've often thought that when countries go to war, instead of having them shoot each other, they should each be asked to solve a problem involving fractions without the same denominator. Whoever gets it first, they rule. What do you think? Less people would die that way. Okay, fractions are your friend. Just remember, 13/15, we're going to multiply by 3/3. So the denominator is now the 45. The numerator is 39. So now I can add the whole number parts and I can add the fraction parts. 5 plus 9 is 14. 25/45 plus 39/45. Well, let's see, 39 and 25, that's for what, 64. So this becomes 64/45. Now, we don't write a mixed number where the fraction part is improper. So what I've got to do now is this. I've got 14 plus, what is that? Let's see, 64 divided by 45 goes in once. And we're going to borrow and carry, and what we get, what, 19/45. Okay, so 14 plus 1 in 19/45 would be 15 in 19/45. Now, I need to ask you, because some of these questions say not mixed numbers. I think you told me it said write it as a mixed number, right? Is that what you said?
Yeah, that's correct.
Yeah, okay. Now, but the other thing would be, will this reduce? Well, 19 is prime. 45 is 9 times 5, 3 times 3 times, it doesn't reduce. So there's your final answer. Okay. My guess is this is the part that you're all still struggling with. Students in
That's-
math. What's that?
That's the part I was struggling with.
Students in math 95. That's the part they still struggle with. Students in calculus. Well, anyway, okay. All right. Other questions? Again, anything to do with what's coming up, any section, anything you want to explore further?
Can we use our notes on the test?
No, sorry, only what you can put between your ears, and I don't want you taking paper and stuffing it into your ear. That's not what I meant.
So does it have to be done on campus then, or can we do it at home?
Oh, you're doing it at your computer by yourself, no help. Go back and look at the test taking policy. Basically, you emailed me back that you wouldn't cheat. So that's where we're at. Okay, so, and it has a whole list of things you're not supposed to do in that test taking policy. You shouldn't be on the phone. You shouldn't be on your, I mean, you're going to be on your computer screen taking the test. That's it. Nobody interrupting, nobody talking to you. And when you're done with your test, if you want to email work to me for problems you missed, do that, but do that right away. 2 days later, no, right then and there. That's basically it. Also, once you open the test, the time starts. So you can't work on it for half an hour and then, oh, I'm going to take a coffee break. I'll come back in a couple hours. Guess what? You're done. Okay. Once you start the test, also don't forget the password. What's the password? Oh, well, this is going to be interesting.
Mayo.
Thank you.
Mayo.
I was going to say, you're going to have a hard time taking the test without the password. I spent months agonizing over what to use for a password, so seriously, I'm just telling you, if you can't remember my name, that's okay. I've had students like 6 weeks into the quarter. Oh yeah, I'm taking a math 40 class. Oh yeah, who's your teacher? Oh, I don't know. Whatever. Okay. So what else? Anything you want me to go through in general? We can sit here and stare at each other all day. Not a good idea, but I mean, we could do that if you want.
Can we look at multiplication of fractions?
Absolutely. Okay, let's see. So the chapter itself section or the chapter review or just whatever?
The review.
Okay. And let's see here. Multiplication of fractions. Okay, that's way down at the bottom. Here we go. And again, if there's a specific question you want, let me know. Otherwise, I'm just going to do the ones that are in front of me. Okay. So this is what I've got. I've got 54 over 3 times 6 over 18. So the long way is to multiply everything straight across and then reduce. The short way is to reduce ahead of time. Let's see. Now, 3 goes into 54. How do I know that? Because 5 plus 4 is 9. 3 goes into 9. But it's easier for me to see that, 3 and 6, I can reduce those. So I'm going to take the easy one. Okay. So that's going to be a 2 over 1. Okay. 54 and 18 are both even. So I know a 2 could come out of those, but 2 and 18 are both even as well. And again, that just seems easier to me. So I'm going to say, let's see, this will be 2 over 18 is 1 over 9. So now I've got 54 over 1 times 1 over 9. Okay. Oh, what times what is 54? 9 times 6. So 54 divided by 9 is 6. 9 divided by 9 is 1. So what have I got left? 6 times 1 over 1 times 1, which is 6 over 1, which is 6. So final answer, just 6. Now, I could have reduced that in a different order. I could have reduced the 6 and the 18 first and made it into 1/3. I could have reduced the 54 and the 3 and made it into, let's see, what is that? Yes, 54 divided by 3. 18 over 1. Okay. In other words, there's more than one way to reduce this. You follow what I'm saying there? Does anybody need me to go back and like do it a different way of reducing? So there's like several different ways you could reduce this down, but the final answer should always be the same as 6. All right, another one. More of those? Yes, no? Nellie, do you want another? No? Anybody else? Okay. Tell you what, let's do one with a mixed number multiplication. So multiplying mixed numbers, what's the first thing we have to do?
make the whole numbers into just fractions.
Yeah, so do something improper, change them into improper fractions. All right. 2 and 7/11. 2 times 11 is 22, plus 7 is 29. So 29/11. 13 and 3/4. Let's see, I shouldn't put an equal sign there. 13 times 4 is 52, plus 3 is 55/4. So now, can I reduce anything? Yes, I can. 11 goes into itself how many times? Once. 11 goes into 55 how many times? 5. That's all the reducing I can do. How do I know that? Because in the denominator, I have a 1 and a 4. 4 would break down to 2 times 2, right? So if I wanted to break it down, 5 isn't even, so 2 doesn't go in. 29 isn't even, so 2 doesn't go in. So there's nothing else I can reduce. So what have I got left? I've got 29 times 5, which is 145 over 4. Let's see here. This says, I got to look at what the not mixed numbers. Okay. By the way, just a little thing. 29 times 5. I did that pretty quickly. You know, I'm bragging. What a great job I did. How did I do that? Here's what I did. I didn't take 29 times 5. I took 30 times 5, which is 150. Oh, but I've got 1 5 less than that because I've got 29 of them. And so what? 150 minus 5 is 145. So that's what I did. Just saying, you know. All right. Something else. Division of fractions, division of mixed numbers. Seeing some head shaking, yes. Okay. So let's do, this is a division problem involving fractions. 6/7 divided by negative 24/49. So the first thing you want to do here is change division into multiplication of the reciprocal. So this becomes 6/7 times negative 49/24. Now the question always comes up, what is the negative sign applied to? Is it applied to the whole thing or just the numerator or just the denominator? And the answer is yes. It's applied to the whole thing or just the numerator or just the denominator, but there's only one of those. So this is not equal to that, because that would be negative over negative is positive. So that'd be like it just evaporated. And in mathematics, when things evaporate, that's not usually a good sign. Okay, we all right that first step? So now, 6 goes into 6 once, 6 goes into 24 4 times. 7 goes into 7 once, goes into 49 7 times. I've still got that negative sign hanging around there. So I've got what? Negative 7/4. And again, the direction said not mixed numbers. And as I mentioned yesterday, when it's asking for a mixed number down below, it gives you instructions on what you have to do in WAMAP for it to recognize it as a mixed number. There's special symbols you put in, and it has that all written down below the problem. So be sure to read before you jump off the cliff. Okay, make sure you have a parachute also. All right, let's take a look at division of mixed numbers. So we've got 2 and 11/12 divided by 1 and 2/3. let's see here. What does it say here? Same directions. So be careful. A reciprocal of a mixed number is not, you don't do that. Change it to improper fractions first. So 2 and 11/12 is what? 2 times 12, which is 24, plus 11, which is 35/12, divided by 1 2/3. 1 times 3 is 3, plus 2 is 5, so 5/3. Okay. So this becomes 35/12 times 3/5. So subtracting a number is like adding its opposite. Dividing by a number is like multiplying by its reciprocal. Down on Yakima Avenue in Yakima, there's a place called Jim and Jenny's Tattoo Parlor. Go in, mention my name so you get the Ben Mayo discount. Have them put a tattoo on the inside of your head, what I just said there, okay? All right. Or you could put it on the back of your neck if we were in class and the person behind you would be able to see it. But anyway, all right, here we go. So now we're going to reduce this down. Let's see. 3 goes into 3 once. 3 goes into 12 4 times. So 3/12 reduces to 1/4. 5 goes into 35 7 times. 5 goes into 5 once. So 35/5 reduces to 7/1. Now that we've reduced it down, we'll multiply straight across. 7 times 1 is 7. 4 times 1 is 4. And again, it said not mixed numbers. And no, I don't have tattoos of math formulas on my body, just in case you were wondering. Okay with this? All right. Do you want more of those or something else? Any questions about order of operations? Which thing comes first? Any struggles there?
I have a question.
Yes.
I feel like it's such a silly question, but it's 11/15 minus 5/15. Wouldn't that just be 6/15?
Okay. To start with, yes, but we can reduce by doing the prime factorization of each, and the 3/3 reduces down. So that's the piece that was missing. So
Oh,
this is true, but unless they tell us otherwise, we're always expected to reduce fractions down to their lowest terms. Okay, unless there's a context where they don't want you to do that. Okay, but final answer, typically you'd reduce it down. Any questions there about that? All right. Anything else? Okay, well, just a reminder, I will be back at 1:15 today with an office hour. Tomorrow morning at 10:30, there will be no Zoom meeting. Well, the Zoom meeting will show up because it's set to go off every day, but I won't be here. I'll be here, but I'll be ignoring anyway. So, and you can take the test anytime as long as you have it finished by 11:59 tomorrow night. So if you start the test at 11:30 tomorrow night, run out of time and send me an email saying, Mr. Mayo, I didn't have time, I will know when you started and I will say, no lollipops for you today. All right. Okay, well, I hope you do well on your test, and I will see you. If you don't come to office hours, the next time I'll see you will be Monday.
Thank you.
All righty. And with that, we'll stop the recording.